All right, let's talk about a real unsung hero of our world, the transformer. I mean, this thing is a century-old giant, and it's the reason everything from your phone to your fridge even works. But what if that giant is, well, kinda obsolete? What if it's time for a total reinvention? That's exactly what we're going to dig into.
Okay, get a good look at this. I know, it might just look like a tower of tech, but what you're seeing could totally redefine our energy future. Seriously. But to get why this is such a big deal, we have to go back. We need to understand the huge problems it was designed to fix.
So, for more than 100 years, right, the good old transformer has been the workhorse of our grid, super reliable. Its job is simple, but it's absolutely crucial. It bumps voltage up and down so power can get from the plant to your house without, fizzling out. But here's the thing. This workhorse was built for a much, much simpler world than the one we live in today.
So naturally, the next big step was supposed to be the solid-state transformer, the SST. And oh man, the promise was huge. We're talking a smart, super flexible, digital version that could handle all the crazy demands of today's grid, renewables, EVs, the whole shebang. It was going to be the future.
But yeah, that future hit a wall, a big one. As engineers started really pushing these new SSTs, they found some really deep fundamental flaws. And we're not talking about little bugs you can patch. These problems made the whole technology unstable, unreliable, and sometimes even dangerous.
And here we get right to the heart of problem number one. These are actually handwritten notes from the source material, and they point to something called severe multiple resonances. What does that mean? Well, think of it like an opera singer hitting that one perfect note that shatters a wine glass. These SSTs can do the same thing with the grid's electrical frequency. They start to vibrate, electrically speaking, and become super unstable, totally unreliable.
Then there's problem two, which is kind of a double whammy. See, these things switch power on and off thousands of times a second, which creates a ton of electrical noise. So you need these huge, really complex filters just to clean it all up. But even with all that bulky gear, they're still totally vulnerable to sudden power surges. Think of them like mini lightning strikes that happen all the time on the grid.
And this really shows you the biggest problem of all. When one of these things fails, it doesn't just quietly shut down. The notes here are pretty chilling. They're talking about explosion of semiconductor modules, spreading of arcs and fire, and yep, destruction of the equipment. This isn't just a bug, folks. This is a catastrophic failure waiting to happen.
So, where does that leave us? We've got this technology that we desperately need for the future of our grid, but it's just loaded with these massive, critical flaws. How on earth do you even start to fix something that broken?
Well, the answer is you don't. You throw it out and you start from scratch. And that brings us to the hero of our story, the MagPower system. This isn't just a tweak or an upgrade, it's a total ground-up redesign, built from the very first bolt to avoid every single one of the problems we just talked about.
And it all begins right here, with a totally new foundation. Instead of that tangled mess of fragile parts we saw before, MagPower is built around this one, single, incredibly robust magnetic core. It's this beautiful, elegant simplicity that's the secret sauce to fixing all those gnarly problems. And then, from that amazing core, you just build it up piece by piece. This modular design, it's not just to look cool, it's absolutely vital for the system's reliability and its power. Hey, remember this picture from the beginning? Now it's not just some mystery tower of tech, right? Now we see it for what it is, the elegant solution to a whole bunch of really tough problems. Okay, now for the really good part. This is the payoff. Let's go through those big, scary flaws one by one and see exactly how this new design pulls it off, how it solves what basically looked unsolvable. All right, so remember that grid instability problem, the dangerous electrical vibrations? Gone. With MagPower, you get proven, stable operation. Simple as that. And what about those massive, complicated filters? Poof, gone. This design doesn't even need them. Next up, vulnerability. How do you protect it from those power surges? Well, the protection isn't some extra part you bolt on. It's built right into the core design. And the high failure rate, solved. It's got inherent redundancy, which means if one part fails, the others just pick up the slack and the whole system keeps on humming. It's built to last. And finally, the big one. That catastrophic failure, the risk of fire and arcs. The old way was a huge risk. The new way, robust isolation with a big safety margin. And instead of some slow, clunky protection system that might not even work in time, MagPower uses a patented, instant protection method. It stops a disaster before it has a nanosecond to start. But you know what? Just fixing problems is only half the story. The real game changer here, the ultimate advantage, is the performance. This thing isn't just safer, it is unbelievably more powerful for its size.
Look, the people who designed this said it best. The key advantages aren't just about what it fixes. This is a huge leap forward in what's even possible. And it all boils down to one single incredible number.
More than 1 megawatt per cubic meter. Just let that sink in for a moment. We are talking about an absolutely insane amount of power packed into a tiny space. So what does a number like that actually mean in the real world? It means you can build power systems that are way smaller, way lighter, and way more efficient than ever before. This blows the doors wide open for things that were just impossible before because of size and weight. I'm talking everything from offshore wind farms to electric ships, maybe even electric aircraft.
Which brings us to the final big question. When you solve all the fundamental flaws of the old designs, and then you achieve a level of power density that was unthinkable just a few years ago, could this reinvention of 100-year-old technology be the key? The one missing piece we've been looking for to finally build a truly modern, stable, and powerful energy future?